Alright, so this lecture is going to conclude a few more thoughts regarding the simple menu example, and then we're going to go into sensors, which is the reason why I wanted to cover this today, because sensors and the concept of sensors is on the exam. Since we just covered the submenus, I'm going to kind of skip through this. We don't necessarily need to see this. However, if you wanted another example, this is what we did. We created this one live. So there's an old tutorial and there's an old project that we'll bring back, and it has the green, yellow, and blue, but ours actually changed the background screen to those colors when we ran it instead of, actually maybe have done this as well, but it also changed the background color. So sensors and actuators is the theme of this part of the lecture. So what do we mean by that? We've seen sensors before, and the sensors before that we saw were associated with the horizontal versus the vertical or layout, portrait versus landscape mode, and the ability of the phone to detect those two changes. So in terms of the sensors, what are we looking at? Sensors that are providing information about the device and its environment. We'll ignore the camera and the microphone for now, but there's also sensors. So when you take a picture, we saw a camera app actually that took a picture and was able to take the picture and upload it to the internet. We also saw, did not see the microphone, however the microphone's done in a very simpler way. In fact, right now Google Play services has recording and actually has information and APIs for the camera as well, but it's mostly for the recording stuff. So it's a lot easier actually. So although the mapping stuff got a bit more complicated, a lot of the other things that are part of the services now got a little bit easier. One of them was the microphone. So it's not really a sensor, but it's working off the same concept. But the sensor we basically set to record or to pick up and to listen to activity versus waiting for something to happen with the phone automatically. So sensor types provided on most Android platforms, we have the accelerometer along with 3 axes that we can work with. A geoscope orientation, that's what we looked at before, the 3-axis orientation or the heading. Light, there's a ambient light sensor. So setting the appropriate screen brightness. We have a magnet field also for car navigation system setup. We have a GPS signal sensor as well. Pressure exerted on the device. We can shake the device, we can drop the device, we can put pressure on the device. Proximity, distances between the devices and targets using electrical fields. So turning off the screen when you're near the ear, so it doesn't accidentally you don't accidentally press buttons. That's how that sensor actually works by default. So proximity between humans and ears and the phones. If you've ever wondered why your phone acts a certain way, sometimes when you go out into the bright sunlight, it dims. Sometimes if you're in a dim area, it will brighten up. When the battery runs low, it will dim. Those are all sensors. Battery indicator is also another sensor that works. Temperature, some meaningful temperature information for ambient battery. You know, when it's hot, the battery actually goes down, so it will lower the battery consumption when there's heat in order to preserve the battery, which is kind of interesting actually. Those are all done by sensors. And battery level, it's also another sensor. So let's look at the different ones. So you may not be familiar with some of the non-common ones. So actuators. Actuators provide feedback to the user beyond the views that we can program. We can access the lights on the device. Notification bar. So tomorrow we'll write a notification tutorial. We'll create another app tomorrow. So tomorrow morning is all about app building. Today I had to get through all the lecture stuff that you're going to need for the exam, but we'll do some fun stuff tomorrow. Vibration, which would force feedback from the device. Those are falling into the actuator category. We have a sensor manager. Just like we have a content manager and a location manager, we have a sensor manager. So Android provides an interface object for us to work with that. So you work with it through the request of sensor information. So we make an instance of the sensor manager, and then we request battery sensor information, or we request light, or whatever it is that we're trying to look at. So sensor manager may be more than one physical sensor that can provide particular types of information. So the user of the sensor manager parallels the location manager usage. So you, as a programmer, request the location manager to provide updates Well, Location Manager actually talks to the GPS, the cell phone tower, the wireless location services to get the data. So you're doing a very similar thing, actually, with the Sensor Manager. So you're getting access to the Sensor Manager. You would use this sort of line of code here that says Sensor Manager, and then you're going to get System Service. It's the same kind of line of code you're writing for the Location Manager. You're getting the System Service, which is essentially the same concept. And then here you're getting the Context Sensor Service. So you might think of this as an extension off of the Content Manager concept. You're making a manager, whether it be a Sensor Manager, a Location Manager, a Content Manager. You're requesting a service from the provider, which is going to be the phone service. That's going to give you information related to, whatever is available. So what is available on my phone? You can ask it actually. So you can request the Sensor Manager to provide us with a list of all the sensors available on the phone. To do that, we say create a list that's an abstract data type list if you're in the Java programming course. Sensor is the data type that's going to be stored in the list. All sensors going to be equal to the Sensor Manager.getSensorList, and then it's going to be sensor type _ all. So you can create a list and then just print the list to a toast message if you wanted to, or just print it out, put it in a list box or something. All the sensors of a given type, examples of the list. Well, this was an old book I used to use for this course that's since been outdated from, I want to say it was somewhere above 2.0 and somewhere around 3, but less than 4. And what ended up happening is everything changed with the higher level APIs, which is why I don't use a book for this course actually, because everything is different for every new API that comes out. So long story short, don't look at that. Instead, do a Google search. So if you do a Google search, you can find, and basically they're going to vary between API levels. So in fact, a lot of the stuff in the emulators varies between API levels as well. But you can get a list of them by just querying the device. In fact, that might be an interesting app that you could probably put together on the onCreate method. Run this here, and then put it into a list box and show it on the screen. And then you should be able to do that, and then you can see a list. In fact, there's an app that does it for you on the content provider. So one of the content provider examples does exactly that. It lists all of the something or other, all of the settings for something, the general settings or something. So in terms of the sensors, we have the listing sensors example here, what's available on the emulator, and here's some source code, or actually an example for you. We have one goldfish, 3-axis odometer, the Android open source project, so an accelerometer. What's available on my Motorola Droid. We've got a bunch of stuff here that might be available, proximity sensors, orientation sensors, light sensors. So this is just an example of a screenshot for it. Once you figure out what sensors are there, not everything is going to be available from the API level. Some of it might be blocked, some of it might be called different. So it's not a bad idea to see what's available, because it means what's not been secured, what's not under lock and key, what sensors can you get to that are associated with the hardware. Hardware will have similar sensors, but not all hardware will be the same. Some hardware will have different devices. So register to listen for the events from the sensor once you get a list of the sensors. So here we have to tell the Sensor Manager which sensor we want to listen for. Again, very much similar to the Location Manager. I want to listen to GPS events. Well, I want to listen to, the events of the light events, or I want to listen to another event. So get a handle to the sensors of interest. You go sensor, create an instance of the sensor object called Sensor Manager.getDefaultSensor with sensor type equal to something, depending upon which sensor you want to go get. So which one you want to go listen to. Or register a listener, the listener to the sensor, and then update. How often do you want to update it? Which is very similar again to the GPS example. The more often you update the sensor listener, the more battery you're going to consume. Not as much as the GPS, but it still consumes battery. So the more sensors you're looking for, there's a kind of a fine line between functionality and a waste of processor power. So In some cases, you know, the sensor that dims the phone when you put it up to your ear, proximity sensors, saves the battery because it dims the whole phone. Why does the phone need to be lit up anyway? You know, make it all black when you're listening to it. You know, the worst thing you can do is just leave it on. It's like a computer, just leave it on all the time. You might as well have it go to sleep, or you might as well have it do something. So, and then on the incoming call, the sensor wakes up the phone and says, "Hey, come out of sleep mode. We have a call coming in, or we have a text message coming in." So, often underlining, you'll need to fill in the specified information for your app down here. So, registering to listen to the events, we can request updates, and then on the updates, we do something. So here we have a registered listener on the event with an update rate. Who's listening to what? How fast are they listening? Well, that depends on your settings in terms of what you're going to do. Here's some examples down here. Usually your class is going to be on the listener, and the listener is going to be set to listen. And the sensor from the previous line of code, here we get the sensor. Sensor is going to be a sensor manager, and then the sensor type. And then the update rate is going to be a sensor delay fastest, delay game, delay normal, delay UI. So we'll see examples of this, and these parameters have changed since API versions have been released. Newer ones have been released with newer sensors. Sensors with different handlers with different rates and different recommendations. So if you go online to the developer, androiddeveloper.com, you can see a lot more of the different specs in terms of what's available. So how to handle an update from a sensor. Employ a sensor listener pattern, as you've already seen for views and for locations and for everything else, actually. Just like a touch listener, just like a click listener, you're going to essentially put a listener on there and then create an observer class to handle the event. So in terms of our sensor listener, in this particular case, we have two functions that are going to be called here. We have an on accuracy change. This is what is this one for? Sensor event listener, just a generic listener. On sensor change, on accuracy change, which means when we get more information in. So we can report a change in accuracy, or we can report a change in value. This is kind of a generic example that's going to apply towards most of the hardware. So now that sensors are used for hardware components, and that not all phones have the same hardware, because we're not working with a proprietary device like an Apple device. We're looking with an open market of different types of hardware. So all your sensors are going to be specific towards the hardware. They're going to be registered, and so one of the main activities that you need to do is figure out what's on there. And then once you figured out what's on there, then you would program a listener. Same way would you program a location listener. And then use an API to essentially run the methods to react to changes in the sensors. So we have sensor events, and the sensor events contain the following information generally in terms of accuracy, which sensor received the event, timestamped, and any values that might come in. Might be, if on a GPS, a sensor event would be a longitude, latitude change or something. Note that they're all public variables, assuming that you have a sensor event variable called event. You don't have to call event.getAccuracy, just do event accuracy. So because they're public, you can get at the properties that are associated with them by just getting at them, because they're definitely accessible. And then we have a value array that might be filled with appropriate sensor values. As an example, we have an array of values that comes through for a GPS change, because what are we going to get? Well, between this update and that last update, you may have moved 20 feet. Every time you move an inch or so, the longitude, latitude is going to change on you. It's not going to be the exact number, depending upon the precision you're working with. So are you going to do a change on all? No, you're just going to get an array and you're going to take the last value. Do we really care about all the intermediate values? Probably not. So sometimes we get an array of values that comes back, and we're just going to pick one. So here's an example code for a light sensor. You can cut and paste this and put this in, although you have to have the light sensor on the phone. Some Android devices actually don't have light sensor. In fact, my Android Samsung doesn't have it. If I go out into, I wish it did actually, if I go out into broad daylight, very bright, I wish the screen would dim actually so I could see it. Or if I'm inside, it would dim. It doesn't do it actually. I can adjust the brightness manually, but there's no sensor that's going to auto-adjust it. Not like the iPhone, or not like some of the other newer devices that are out, but that's an old device. So unfortunately, when it comes to sensing, when I use this one to test with, no sensors. Problem with the sensors is when you go to test with it, you actually have to have the device. You can't sense it on the emulator. How are you going to emulate a light change? It's just like the GPS stuff. How are you going to emulate the GPS change? Location change, you know. What about proximity? You know, hold up the computer to your ear. It's not going to sense anything. And it obviously doesn't sense the vertical versus a portrait versus landscape either. So if you're going to do this, you're going to have to test it on a real device. And the sensor activity here is going to implement sensor listener, sensor event listener. And the sensor event listener is going to be placed on any on a system resource that you're going to be listening to. So you're going to get the sensor list and you're going to put it the listener on it. So listen for light. So the sensor light sensor is going to be a new default sensor for light. So. And then on destroy, you're going to get rid of the sensors because those are going to be time consuming. So after you're done, you're probably going to load up the app and you're going to close down the app. You're not going to leave the app open. If you have an app that's going to be running in the background or leaving it open and paused and the sensors are running, the sensors aren't going to pause. And you're going to get yet another experiment in how fast can we wear down the battery. So you can create a GPS app that just wears the battery down constantly as well. Usually those programs you load it up and you close them down. You don't normally pause them. If you do pause them, you're not going to get as much battery life as you might expect. So if you run this, this is the output of this code, and you might look at this and go, well, how do you do that? That's all the code. In fact, you don't even have to put anything on the interface file on the layout. It just does it for you. So it's a text view that's going to be loaded. So here's a sensor example for the accelerometer. So we have imagine the device sitting on a table. We have the top, the bound, then we have an X and a Y. We have the where is the device in terms of its location in the plane. We have lateral movements. So accelerometer is going to go picking up the movements, shaking movements, dropping movements, tossing movements, and sort of think of it like a Wii system or an Xbox system. And you can actually use it. It's not very efficient, but you can do an iPhone, or excuse me, an Android app that works sort of like a Wii app, where it kind of simulates a motion. Although not going to last as long on the battery as a Wii remote or a Xbox remote. So imagine the device sitting on a table. We have the X-axis, the Y-axis, the Z-axis. So there are built-in constraints in the sensor manager class that you can use to normalize some of these, and then look for changes. Include a gravity of the Death Star. I don't know. Anyway, so you can attempt to detect being picked up, being fallen, dropping down on the ground. Actually, one of my students actually did this because the accelerometer is actually quite easy to implement. So you can drop the phone, but how often are you going to drop your phone? So you can drop the phone and the phone goes, ouch! You know, you just play an audio file when the phone drops. Or you pick it, hey, hello, you know, wake it up, you know. So the easiest thing to do is make some audio tone because you can't see the screen. So when the motion and actually the audio actually goes out before the phone actually hits the ground. It's on the downward motion. It would actually, and then you can catch it hopefully before you drop it. You can throw the thing around enough, you're going to break the device. It's not worth it for testing. But it's actually kind of funny. You can put little noises in there. You can go, ouch, or you can when you pick it up, it can wake up, you know, say, hello, you know, or leave me alone, or I'm sleeping, you know, which is actually kind of funny, but it lets you know that the phone is actually picking, it's the phone sensors that are picking this stuff. Well, it's the same thing you get when you hear the ringtone, calls coming in, ring, or an audio tone on a text message. It's the same concept. So here we have an attempt to detect being picked up or falling. Reading from accelerators comes quickly, very quickly. Average lasts about 10 readings compared to plus or minus a little noise, a little variance. Not exactly 100%. In fact, it takes a few minutes actually for sensors for incoming broadcast receivers actually to pick something up. So you pick a range and you go, well, if it's moved within this particular range of values that you've received, then it's falling. So you're defining the condition by the amount of readings that you're getting. Holding in my hand might lead to this here, a sharp upward movement. You know, it can go put me down, but it's hard to read the phone to know what it's doing. So if you put an audio thing in there, it says, I'm going up, I'm going down. You know, you can make it to the left, to the right. You can essentially audio hear what's going on. So.
There's a sensor in this that actually drained my battery, and it's like an eye symbol. So every time you look at the phone, it realizes you're looking at it and it turns on.
Yeah.
So light comes up. So it doesn't work very well. So I had it on one night and the battery was completely out.
Sensors will drain your battery.
That one was. I mean, I have other sensors on it, but that particular sensor was really bad.
You know why? Because it's constantly working to pick up. I don't even know what it might even be reading. How if the screen? I thought I heard something. I think that's my phone. It's probably picking up some sort of. It's probably the camera's probably on constantly. Is what I'm thinking. It's probably picking up the face or some object recognition, and then once it picks up something, which means the camera's on constantly, which is the same problem you have with the GPS. It's constantly pinging at some interval the status of your location and constantly updating location. The GPS will wear your battery down within an hour of usage, and I'm sure that probably did something very similar to it. So. Now, the sensors, one of the bad things about batteries is the sensors will wear your battery down. But for playing around with it, you don't want to leave this one on too much either, because this one's, the accelerometer is constantly picking out, you know, am I still? Am I moving? Am I still? Am I going up? Am I going down? So it's constantly pinging the sensor. Although it might be fun to play with, you want to turn it off when you're done playing with it, because it's not gonna give you good battery life. Actuators are another one, provides you feedback to the user beyond the views of the activity. We can have a status bar, icon messages, extended status bars, lights on the device, vibrators, those are actuators, ringing, so you can employ all the notification frameworks as well as some of the ones independently. What we're going to do tomorrow morning is build a notification. So we'll be sending our phone some notifications, and then through the app. So the activity will just work with the sensor to send it a notification after notification, or as many as we want, actually. So, which is actually kind of interesting because it shows you how to work with the sensors. It's about all we can do on the emulators to send a notification. If you don't have an emulator, if you don't have a real device, it's hard to test the sensors. Actuators here, we have a hardware light here on an Android that has with multiple colors that comes on. So we have a status bar on the top, and then we have the status bar below it with no notifications. So this is an example of the status bars. So employing the notification manager, this is the example we're going to see, which is why this lecture to end with today is a good one to start with for tomorrow, so if you can remember. And I'll review the concept a little bit before we start it, but it's like the location manager and the sensor manages the notification manager. So each one of these sensors, just like location, sensor, notification, is yet another manager. Why they call them managers, I'm not quite sure, but this manager here is going to use the same syntax as before it gets the system service. So this is kind of the generic method call given, you know, context.notification service in this particular case. So the parameters are different. The method calls are pretty much the same between all the different location managers. Here's the status bar. The notification manager here, the status employs the icon to be drawn. We'll stick an icon and we'll stick some text tomorrow on a notification. And we'll call the notification bar and see when it's come through. We'll say, hey, it came in. So we'll check for it. We'll send one and then we'll check for it to see if it has come in. Then we have a ticker text to be shown on the bar itself, and then a time of the notification for appropriate ordering in milliseconds, so we know which one was sent first and second. Because what the interesting thing about the sensors is, how do you know what order everything was received in? You don't. It just kind of gets queued up. It's kind of like sending signals, capturing signals on an operating system. You can generate a bunch of signals. Which ones of them are going to be caught? Which ones are going to be stored? Well, they're going to be queued up. And then you have to go through the signal manager, signal handler to essentially go, which ones you do want to deal with when they arrive. It's just kind of like the sensors, which one, how often do you want to check for this change, and then when the change happens, what are you going to do? So times of notifications here, extended status bar for application context, for title, ticker text. So we'll look at this hands-on tomorrow when we look at the notifications. To use it, we create a notification, we add the information for the extended status bar, we send the notification manager, and then we look for it, and we cancel the notification, so which is what we'll see tomorrow. In terms of the status bar, we create the notification, and we can have a notification is going to be equal to a new notification, and then we can have a drawable icon. So we can use anything that we want. Could you guys take the conversation outside? I can hear you all the way up here. It's bugging me. Everybody's like loud today. Okay, so I'm just going to finish this up. Get through the day. Anything that's in the drawable directory can be used anywhere, even on a notification, even on on a map, anywhere we want in the application. So we can add an extended status bar information by using this method here, set latest event information. We can create the notification by creating a notification object. We can send it to the notification manager by sending notification manager.notify, and here's the notification we want to send you. And then eventually we can cancel it once we've sent it, if we have sent it. Because what we're going to do is probably send it a couple of times and then we'll cancel it, which removes it. So we can cancel notifications from the notification bar as well, rather than having the user do it. And this is what we're going to build tomorrow, actually, something very similar to this. So this is actually kind of a cool thing to see. So we have a status bar up here that says a button pressed. So we can pull down the notification. It's a matter of just dragging down the top. This will work in the emulator, by the way. We can put everything. We can put buttons, icons, items, anything we want can show up in the notification. Normally you don't see very much. You just see text or you see an icon. When you install apps and stuff like that, the application manager will send a notification of say, hey, it got updated, or we need this update, or something like that. So if you fill it up too much, the user gets irritated by it because there's too many notifications. So there's a lovely little clear button normally on the notifications. You just clear it all out if you want. So actuators and notifications, the bells and whistles, notification bells and whistles such as lights, sounds, vibration are associated with notifications. So the notification of an incoming call usually sends out a ringtone. So you just say, hey, play this music, or do something, or light up the phone, or vibrate the phone, which is all the options that you normally get to receive calls and text messages. So you build a notification using the approaches that we just looked at a few minutes ago, and then associate them with extra features. The extra features are going to be, as an example, vibrate. So you can actually write an app that just vibrates the phone if you want, every 5 minutes or something. Which might be nice for a little notification for like a time scheduler program, and they have them out there actually. So you can write your own though really easily by just putting a little clock in there, and then after every hour, play an audio tone that says, hey, it's lunchtime, or hey, check this, check that, or little notes to self or something. Yeah. Or alert. Actually, that's how calendar alerts are working. They're sending you a notification that says, hey, your lunch appointment's now here, or it's time for your meeting. So requires permission to vibrate. So we have in here permission. Actually, all of them require permissions because the manifest isn't going to let us contact any of the stuff unless we set a permission for it. So we have to use permissions for the sensors. Same thing as we did with the GPS one, the location one. This one here is for vibrate. So this is permission vibrate. So it defines an array of longs which contains several different on, off in milliseconds. So how long do we want to send it for? So set notification.vibrate, which is a variable to an array specified above, and it sets it. So vibrating the phone, making sounds is probably the most popular thing to do. Any sound can be associated with a notification, so we can send a sound along with a notification. So notification.sound variable to a URI of a location on the phone where it points to a sound, an audio file. So it can access default ringtones through the ringtone manager. Actually has separate defaults for alarm, notification, and ring. So we can set it the ringtone to come off every 5 minutes or something if we wanted to. Lights kind of work the same way. We can actually set colors. Depends on the hardware again as to which light function is going to work. So you can set the color of the light can be constructed from an RGB color. So this again is depending upon, in fact, same with all of these features, depending upon what hardware is going to be supportable on the device. Most devices have lights, although this one doesn't. It has audio, has vibrate. This one doesn't vibrate either though. Which is kind of interesting. So it's not a phone, it's a tablet. So I don't think tablets vibrate in general. So I don't know, could be wrong. I haven't seen them. You know, my iPhone, no, my iPad mini vibrates. I think. I could be wrong. This one makes a vibrating tone. He goes, zzz, zzz. And I'm like, what are you doing? Zzz. When I turn it on, it goes, zzz. I'm like, you're not moving, but you're making a vibrating tone. So, which is funny, because how did we come up with a vibrating tone? You know, it's just like, you know, ringtone, I guess. Alright, so we can set the color here. This one doesn't do color, so it's lost on this one. Notification.LED RGB colors for some color combination that we can set. And we can set the light in milliseconds. Turn it on, turn it off, and then show the flag to show the lights, and then the notification.flag. So unfortunately, it's kind of like the mapping features playing with the actuators may or may not necessarily lead to predictable results. And it might be a matter of setting the milliseconds. If the on and the off is too close together, you may not actually notice the effect. May not actually show any light, so you might have to leave it on longer than you would like to in order to actually see it work. So anyway, that's the information I wanted to give you on the sensors on the device. So tomorrow morning what we're going to do is build one that uses notifications and make sure that we can kind of see that programmatically. I also have a couple of other tutorials we'll run through tomorrow, but not too much of the lecture stuff. I did all that stuff today. Do we have questions, comments, or concerns? I'm sorry? I am trying to wrap it up. Huh? The concept of sensors is on the exam. It's a multiple choice question, actually. It deals with common sensors. And you pick amongst the ones that are available, and there's like options that have 3 or 4 of them in there. For people who have never heard of an accelerometer, that's one of the options. You know, it's like to trip you up, because you look at that and you go, is that really a sensor? But after looking at this, actuators, accelerometers, you've already heard the buzzwords. That's why I say it's kind of easy. When you look at the exam, if you've seen this word before, you might recognize it in one of the options. Also, but you know, if you haven't seen it before and you just left about an hour ago because you showed up to sign the attendance list and you really haven't been here and you don't know exactly what I'm talking about, then you might not notice that. In fact, it's terrible, but people miss the question. You'd think they wouldn't. So anyway, let me end this lecture here before I